Good day, viewers! For today's video, we will discuss the entity relationship diagram and its terms and concepts. First, we will have a short discussion about the database. We provided 4 tables as our examples.
A database is a structured and organized collection of data that is stored electronically in a computer system. For table number 1, customer, it contains 5 fields: customer ID, the primary key, first name, last name, email, and phone number. It also shows 5 records. For table number 2, products, it shows 5 fields: product ID as the primary key, name, description, price, and category. For table number 3, orders, it contains 5 fields such as order ID as the primary key, cost ID serve as the foreign key, order date, total amount, and status. For the last table number 4, order details, it shows 5 fields: order detail ID as the primary key, order ID serve as the foreign key, product ID, quantity, and unit price.
Primary key. A primary key is a unique identifier for each record in a database table. It ensures that no 2 records have the same value in the primary key fields, making it a critical element for data integrity and relational database design. For this table, the primary key is the cost ID.
Foreign key. First of all, what is foreign key? A foreign key is a field in one database table that is used to establish a relationship with the primary key of another table. It enforces referential integrity, ensuring that the value in the foreign key match value in the reference primary key. The primary key cost ID will use in table 3, order, and will serve as a foreign key.
Composite key. A composite key is a combination of 2 or more fields in the database table that together serve as unique identifier for each record. It is used when a single field cannot provide unique identification in its own. In this table, the customer first and last name will be the composite key.
Cardinality. Cardinality represents the numerical relationships between records in 2 related database tables. It describes how many records in one table correspond to how many records in another table within a specific relationship. Cardinality can be 1-to-1, 1-to-many, or many-to-many.
Cardinality relationships. 1-to-1. Each record in one table is associated with one record in another table. 1-to-many. Each record in one table is associated with multiple records in another table. Many-to-many. Multiple records in one table are associated with one record in another table. Many-to-many. Multiple records in one table are associated with multiple records in another table through an intermediary table.
In a database context, a relationship defines the logical connection between 2 or more tables based on common fields. It determines how data in one table relates to data in another, enabling data retrieval and manipulation across related tables. For table 2, it has 1-to-1 relationship. Product table with additional detail order details which each order has only one associated product. For table 3, it also has 1-to-1 relationship. Product table with additional detailed order details where each order has only one associated product. For table 4, it has 1-to-many relationship. Orders table where each customer can place multiple orders.
Weak entity is an entity that does not have a primary attribute of its own. It relies on the related strong entity to provide part of its primary key. For example, a weak entity type is an order. It has no meaning by itself. It must be placed by a customer, so it has a foreign key relationship to the customer table, but it has several attributes of its own. For example, removing the primary key order ID in the table order, it will be weak entity. Identifying attribute and identifying relationship is used to connect a weak entity to its related strong entity. The primary key is the strong entity it used as part of the weak entity's primary key. For example, in a table order, without its primary key, order ID, the identifying attribute will be the cost ID.
Derived attribute. A derived attribute is an attribute whose value can be calculated or derived from other attributes in the database. It is often denoted with a dash ellipse. For example, in table order, the total amount is derived from the attribute quantity in the table order details. The attribute total amount will be dependent in the other attribute.
What is an ER diagram? An entity relationship diagram, or ERD, is a visual representation of different entities within a system and how they relate to each other. So it is also a tool used to design and model relational databases and shows the logical structure of the database. And ER diagrams use symbols to represent entities, attributes, and relationships, which also helps to illustrate the relationships between the entities in the database. And ER diagrams are commonly used in software engineering and database to help developers and stakeholders understand and design complex databases.
In this diagram, it will illustrate the structure and relationship between our given examples table: customer, order, order details, and product. The entity customer places orders. In entity order, it shows order details. The entity order details will contain the entity products.
So let's break down the components of this ER diagram. So we have entities, customers, product, order, and order detail. So now, let's discuss the attributes. In customer, it represents the customer's table with attributes like customer ID, first name, last name, email, and phone number. So in product, it represents the products table with attributes like product ID, name, description, price, and category. So in order, it represents the orders table with attributes like order ID, customer ID as the foreign key, order date, total amount, and the status. In order detail, it represents the order details table with attributes like order detail ID, order ID as the foreign key, product ID also as the foreign key, quantity, and unit price. Relationships. Customer and order. It is a one-to-many relationship. Between customer and order, each customer can place multiple orders, but each order is associated with one customer. Order and order detail. It is a one-to-many relationship. Between order and order detail, each order can have multiple order details, but each order detail is associated with one order. Product to order detail. It is a one-to-many relationship. Between product and order detail, each product can appear multiple order details, but each order detail is for only one product.
In entity relationship diagram or ERD, total of the partial participation are the concept used to define the minimum and maximum participation of entities in the relationship. Here are the definition. Total participation. Total participation in the relationship means that every instance of an entity must participate in the relationship. Partial participation. Partial participation in the relationship means that some instances of the entity may not participate in the relationship.
Here are the examples for total participation. For the first one is the customer's table. This table could have total participation in relationships where a customer must always be associated with an order. For example, in the orders table, the customer ID field is a foreign key that links each order to a customer. Her total participation means that each order must have a customer associated with it. If a customer places an order, their participation is total because an order cannot exist without a customer. Second one is the order details table. The order details table often has total participation in relationship because it represents the specific items or product. Within an order, each order detail should be associated with a particular order and the particular product, so both order ID and product ID fields typically have total participation.
In partial participation, we will have these examples. First is orders table. The orders table could have partial participation in relationships where an order may exist without any order details. In the order details table, the order ID field is a foreign key linking each order detail to an order. While most orders have order details, there might be cases where an order is placed but doesn't immediately have details. So the participation here is partial. Second one is the products table. The products table typically has partial participation in relationships because a product can exist without being part of any order details. In the order details table, the product ID field is a foreign key linking each order detail to a product. Not all products need to be included in orders, so their participation is partial.